I'm going to briefly demonstrate how to use a digital experiment where students will take data. In this experiment, we expand an ideal gas that's in this tank on the left at high pressure and elevated temperature. And by opening these valves, we expand it into another tank. We can change the volume of each of these tanks until we reach equilibrium, the same pressure in both tanks. And we can read off the temperatures of the two tanks. We can also read the pressure, and I'll show how it's easy to read the pressure on the actual simulation. The simulation is located on our website that's given here, and the idea is that we'll use mass balances, energy balance, and the ideal gas law to evaluate the data, and I'll show that now on the actual simulation. So here in the simulation, we can select the volumes of two tanks, and we can change the pressure, the starting temperature in the left tank, and then open the valves by clicking on them on each tank. And then when I open the valve connecting them, we'll see the temperature dropping in the left tank. It's undergo adiabatic expansion, and the temperature rises in the right tank. We can use the zoom to get good measurements, so we can zoom in with the scroll wheel to make it easier to read the pressure and to read the temperature. So the two pressures and the two temperatures we can read reasonably accurately, and then we can apply calculations. So the calculations are given in a worksheet located here. So the worksheet is a PDF file that we can download and follow steps that lead us through what measurements to make, what calculations to do. The idea of the experiment, it takes somewhere between 30 and 60 minutes to carry out the complete worksheet. Hopefully it gives a better understanding of adiabatic expansion, first law, mass balances, and ideal gas law.